All right, so this is an example for chapter 22. We're comparing proportions, and the scenario is that we have people trying to quit smoking with the patch, the nicotine patch, and we randomly put them into two groups. One not only has the patch, but also has a support group, and the other has the patch, but there is no support group. And after 6 months, this is their success rate for quitting smoking. 46 out of 143 of the support group people successfully quit smoking, and 30 out of 151 of the no support group. So we want to know if there's a statistically significant difference. Is there evidence that being in a support group will help you quit smoking? We have our null hypothesis, and this is this idea of a null, nothing is different. I'm going to say that the proportion of people who quit smoking with the support group minus the proportion of people who quit smoking without the support group, no versus support, is 0. There is no difference. Our alternative hypothesis is that the difference would be greater than 0, right? That having a support group would make it more likely that you would quit smoking. So here are all of our numbers. The number of people in the support group is 143. The people that are successful quitting is 46, and therefore the proportion is 0.322. The number of people not in the support group is 151. The number that successfully quit without support is 30, and therefore the proportion is 0.199. And if we want to make sure we can use a normal model, it's in the situation they were randomly selected to be in each. We can assume each person quitting smoking is independent from the next, right? If Steph quits smoking, that shouldn't have an effect on whether I do or not. And that the number of successes and the number of failures in each group, is greater than or equal to 10. Now here's the key to this chapter. If we are assuming there is no difference in the proportions, when we make our model, we use a pooled standard error. So what that means is first we want to find a pooled proportion. So we want a p hat pooled. So that's going to be 46 plus 30 people out of 143 plus 151 people. So the total number of people that successfully quit smoking was 76 out of, what is this, out of 294? And evidently that works out to 0.259. Does that make sense? Yeah. So there's a pooled proportion. If we're assuming no difference, it's kind of like saying, well, the average number of people that quit smoking is 26%. And then we find a standard error that is also pooled. So how do we do that? Well, we use this proportion as our p, 0.259, and so the people that were unsuccessful is 0.741. And remember, since we're finding a difference, you add the variances. Do you guys remember that? That idea of when you're finding a standard deviation of whether you're adding or subtracting, you always add the variances. So that's what we're doing here. And, I don't know what that works out to be. I don't have my numbers. But evidently now we can find a z-score. And our z-score is our ps minus our pn over our standard error. And in this case, it works out to be 2.41. So what do we already know if we have a standard deviation of 2.41?
Abnormal.
Yeah, it's unusual enough that we think that you're more likely to quit smoking if you have a support group. But we're no longer just using a z-score. What are we using? What do we want to find? We're 2.41 standard deviations. What do we want to know? The p-value, the likelihood of getting this result. And that's when you use normal CDF, right? Normal CDF, and I want to go from 2.41 standard deviations away to 99 standard deviations away. with a mean of 0 and a standard deviation of 1, and that works out to be 0.008. So this is the likelihood of finding this difference, the support group minus the non-support group, if there truly was no difference. So the p-value is low enough, and this goes back to chapter 20, that we reject the null hypothesis. The null says there was no difference, so if we're rejecting the null, there is reason to believe that you are more likely to quit smoking if you have a support group. This is taking a little extra time. But that's the procedure, except now we're looking at a difference. Our null hypothesis is there is no difference between the two groups. Since we think there's no difference, we do a pooled standard error. And again, we're adding variances between the two groups. We find a z-score. We convert the z-score to a p-value. That gives us the likelihood of actually finding this in the sample. It's low enough, so we reject it. So now if we reject it, we want to do a 95% confidence interval. We want to know what the difference is. How much more likely are you to quit smoking if you have a support group? And so we find the difference between the support group and the non-support group.